Hi again, welcome back. In this video, we begin our discussion on the development and use of a general term to describe our arithmetic sequences and series. In the previous video, we established the ideas of sequences and series and some basic symbols. We now examine the first of two simpler series, and the one we're doing here is the arithmetic sequence or the arithmetic series. Obviously the same, do we use commas or plus signs? So take 4, 9, 14, 19, 24, separated by commas, therefore a sequence. Here we have written down 5 terms. The dots at the end indicate that there are more terms in the sequence. Now the common difference between the successive terms is clearly 5. And to determine that difference, we always look at the difference between any term and the one before it. So if we take the first two terms, we've got 9 minus 4, which is 5. Next two terms, 14 minus 9 equals 5. So here what we are doing is adding 5 to any number to get the next term. If we found that there was not a difference of 5 between all of these, then that would not be an arithmetic series. One exception breaks the calling it an arithmetic. So we aim to determine by this difference, how do we move through the series? We cannot say first term minus second term, for example, 4 minus 9, because that would give us minus 5, and that would be a very different series involving subtraction. And so for an arithmetic sequence, we always have a difference between successive terms. If we want to write the arithmetic series, then we use plus signs, and therefore we would write this one as 4 plus 9 plus 14 plus 19 plus 24 plus etc. There's not much difference really between what we're doing with the series and what we're doing with the sequence, so you can keep on alternating at this stage, except in certain circumstances when it is important to say series rather than sequence. So let's have a look at this one. First term we're going to write as T1. And that's going to be 4. The second term, T2, is 9, and we could have broken that down into 4 plus 5. The third term, T3, is 14, and so 14 is equal to 9 plus the common difference, 5, and then we've got 9 is 4 plus 5, so it's 4 plus 2 times 5. The fourth term, T4, is 19, same sort of deal, 14 plus 5, which is 4 plus 2 times 5 plus a 5, which is 4 times 3 times 5. So you can see that the number in the left, the term number, the 4 for example, is mirrored by a 3 on the right hand side. The 3 has a 2 on the right hand side. The second term has really a 1 times 5 in on the right hand side. So we have a pattern here that we can follow. If we wanted to write the 10th term, then we're going to say it's 4 plus 1 less than the 10, which is 9 times 5, so our 10th term is 49. So it's a nice quick way to be able to see what's actually happening to get this nth term. For the general term, which we're going to call the nth term, where n is going to be any number, and we write Tn, well, we can write that as the first term, T1, plus n minus 1 times d. So to remember this, what you ought to say to yourself is that the nth term equals the first term plus n minus 1 times the difference. Easy to do, good to remember. So let's have a look at this general result in practice, and you're going to be doing this time and time again. For the arithmetic series 2 plus 4 plus 6 plus 8 etc., we have to find the 23rd term. So let's write down our basic ideas. The first term, T1, is equal to 2, and the common difference is 4 minus 2, which is 2. So we know that the 23rd term, T23, is equal to the first term, 2, plus 23 minus 1 times the difference, which is 2, and that gives us 46. If we wanted to find the next term, then we know that we can simply add the common difference, because that's the difference between the 23rd and the 24th term. So we have 46 plus 2, which is 48. If we wanted to go again, another 25th term, then it's 48 plus 2, which is 50. And we can keep on adding 2 to go up one at a time. Very rarely we want to do that, but at least we can see what the pattern is. If we wanted to go backwards and find the 22nd term, then we're going to take the 23rd term and take 2 away, because we're going back down the series. So it's 46 minus 2, which is 44. Pretty important that you can see that. You're going to require that idea in the back of your mind quite a number of times. Before looking at another example, we'll just pause briefly to have a look at the computing formula for our nth term. And that is Tn is equal to T1 plus n minus 1 times d. Now if we expand that, Tn is equal to T1 plus Dn minus d, and then we can combine T1 and the d into brackets and leave the plus Dn outside. Now the bracket has got 2 terms in it which are both constants for a given series. The second term, the Dn, d is a constant or a number, and n is our independent variable. So we have an equation here which says that our dependent variable Tn, the thing that we're trying to predict, is equal to some constant plus a constant times our independent variable of n. Now that's exactly the same situation as you're all used to, which is y equals a constant plus mx, the equation of a straight line. And that straight line has a gradient of m. Now if you have a look at my graph, you will see that I've drawn a line which is y equals 3n minus 2. I've also written down our formula for Tn is equal to the first term plus n minus 1 of the differences, and I'm based here on a arithmetic series with a first term of 1 and a common difference of 3. So that's why I've got a 3 in that part of the equation. Now if I put T1 as 1 and rearrange my terms, then I get 3n minus 2 as the computing equation for Tn. It's exactly the same as what I'd drawn for the y. So if I look at this line and I go from term 2 to term 3, my value of Tn increases by 3. If I go from term 4 to term 5, my term value increases by 3 again. In other words, my rise over run, my gradient for the line, is exactly the same as my common difference in my arithmetic series. So the gradient of a line is just the common difference of our series. In our general term formula, we really have 4 variables: Tn, first term T1, our common difference d, and the number of term, or the term number, as n. So the questions are going to be made up saying there's 4 variables, we'll give you 3 of them, and you calculate the other one. So it's just a matter of substituting into the formula to find out which one you want. So another common question is, for the arithmetic sequence 6, 12, 18, 24, 30, which term is 234? Here we've got to find n, we're given the other 3. So the Tn is 234, the first term is 6, plus n minus 1 times the common difference, which is 6. So tidying that up, we have 234 is equal to 6n, so n is equal to 39. So the 39th term is 234. Another sort of question you can get, which is fairly common, is that you're told that in a given series, arithmetic series, the 4th term is 17 and the 10th term is 41, and you've got to firstly find the first term and the common difference and then something else. Generally these come in with 2 bits in them. So we write down what we know. T4 is equal to 17, and we know how to calculate the 4th term because it's the first term plus 3 times differences. And we're told that the 10th term is 41, so we do the same thing. T10 is equal to 41. which is equal to the first term plus 9 differences. So we have two simultaneous equations in two unknowns. We just got to solve that. Always you're going to subtract because it's going to get rid of the T1 term straight away. So 41 minus 17 is 24. 9d minus 3d is 6d. Divide by 6d is equal to 4. Substitute back into one of them, say to T4, and you get T1 is equal to 5. So now we know the first term and the common difference. Now we need the first term greater than 220. Well, we'll call 220 our Tn term. So 220 is equal to the first term, 5, plus n minus 1, we've got to find the n, times the common difference, which is 4. Tidy up, 219 is equal to 4n. Divide by 4 and we get 54 point something or other. So round it up because we have to have it greater than 220. So we're going to take n as the next whole number, integer, of 55. So the first term greater than 220 is the 55th term, and substitute into your normal formula and you find that's 221. Report both of those just in case they want both. Sometimes they only want one of those, but be safe, give them both. We've got a number of questions, quite good questions too, that simply state that we have three terms which form an arithmetic sequence or an arithmetic series. Nothing much more given to us. So in all those sorts of questions, remember that if we're talking about an arithmetic sequence or whatever, that implies that we have a common difference between our terms that they've given us. So go ahead and determine a common difference. For example, they might say the values 20, x and 54 form an arithmetic sequence. Find x. Oh, where do we start? We start with the difference and we determine the differences from successive pairs. So our first difference that we can see is x minus 20. The second difference is 54 minus x. We know that those two differences are the same because it's an arithmetic sequence. So equate them. Tidy up. 2x is equal to 74, x is equal to 37. So the middle value between those is 37. Don't just go and say, oh, well, I'll average, because sometimes the question's going to have, there are 3 numbers or 4 numbers between the two end ones. So just take this approach, look at your differences first. So to summarise, how good has this topic been? Fabulous. A sequence is a collection of numbers. We write these numbers with commas between consecutive values. A series is a sequence of numbers which are connected by addition. An arithmetic sequence or series has a constant difference between consecutive pairs of numbers. So the numbers 1, 5, 9, 13 and so forth is an arithmetic sequence with a common difference of 4. It's got commas. 1 plus 5 plus 9 plus 13 is an arithmetic series with a common difference of 4. It's got plus signs. So the general rule, the general term, the nth term of an arithmetic sequence or series is determined by our statement. The nth term is equal to the first term plus n minus 1 times the common difference. Just keep on saying that to yourself. If you need to formalise it, then we can write Tn is equal to T1 plus n minus 1 times d. So you should now have the steps to develop and use an expression for the nth term of an arithmetic series. Hope I have helped you to clarify the concepts. Thanks for watching this video. In the next video in the series, we look at developing and using an expression for summing n terms of an arithmetic series. Hit the like button and subscribe if you haven't already. Also, go and do some questions and test yourself one on my website at drjsmaths.com. Just click the back arrow and you'll get there. Add a comment or send me an email if you have any questions. Good luck. See you when we're summing.